All right, let's do an example from homework. We're going to use the second derivative test to find all local extrema. This is also known as relative extrema. If you're looking at other videos from other sources, it's the same thing, if the test applies. Otherwise, we're going to use the first derivative test. The only place where the second derivative test doesn't apply is when the second derivative is undefined. So if we run into that, we'll talk about it. Okay, so we've got this function. We need to find the first and second derivative and go from there. All right, so here's the function that we're given. So the first derivative is 4x cubed minus 36x squared, easy peasy. And then the second derivative is just the derivative of the first, which is 12x squared minus 72x. All right, so in order to figure out the contestants for local maxima and minima, they are the critical values, which is, we use the first derivative to find those. Remember that where f prime of 0, where f prime of x equals 0, or where f prime of x is undefined, that's where we find our critical points. Okay, so 4x cubed minus 36x squared is never undefined because it's just a polynomial. There's no derivative, or there's no denominators that might have a 0 in them. So we just need to know where this is equal to 0. So we take 4x cubed minus 36x squared and set it equal to 0 and solve for x. I can take out, let's see, a 4x squared, and then I'm left with an x minus 9 equals 0. And this happens, this is true, where x equals 0, excuse me, where x equals 0 or x equals 9. Okay, so those are our two x values that are possible max or min, local maximum or minimum points. So in order to figure out whether they're maximum or minimum points, we're going to use the second derivative test. And all that means is we're going to find f double prime of 0 and f double prime of 9 and see whether the function is concave up or down there. So for my x values, I have 0 and 9. Those are our two places where we're going to check. And what we're checking for here is the sign of f double prime of x. Okay, so f double prime of 0 is 12 times 0 minus 0, so in other words 0. Oh, so f double prime is 0 there. So it's neither concave up nor concave down, so this is one of those cases where the second derivative test doesn't work. So we'll have to use the first derivative test on that one. We'll do that in a second. Let's see if the second derivative test works for this point 9 though. 12 times 9 squared is some big number, and it's a much bigger number than 72 times 9, so this is going to be a positive value. Okay, so the positive value means, we don't know yet on this guy, but the positive value means that at 9, the function is concave up. Okay, and when it's concave up, it looks like this. In other words, this is going to be a minimum point. Max or min. Okay, and then we just need to know what the function value is here so we can give it to the our homework. So f of x. In other words, what's the y value for 9? So plugging in here, we've got, gosh, 9 to the 4th. Some craziness. It turns out that's this ginormous negative number, negative 2,182. Okay, and since we know that at x equals 9, the function is concave up like this, then we know that at 9, we have a local minimum. So min at 9, comma, negative 2182. All right, so what's happening at x equals 0? In order to figure that out, we need to know what's happening before and after 0. So we're going to use the first derivative test. So recall that we would make this lovely little number line, and at 0, f prime of x is 0, right? Because if you plug in 0 here, you've got 0. That's how we know that it's a critical value. So then we just need to know what's happening to the left and to the right of the 0. So at, let's say, -1, we're going to check the point -1. F prime of -1 is equal to 4 times -1 cubed minus 36 times -1 squared, or -4 minus 36. Yeah, that's negative also. So it's negative. All right, so the function's decreasing. Right, the slope of the tangent line is negative to the left of 0. And then let's check a point 1. All right, so f of 1 gives us what? I'm sorry, f prime of 1. 4 times +1 cubed minus 36 times +1 squared. And that is, oh gosh, that's just 4 minus 36, which is negative. So it's still decreasing. Okay. So at x equals 0, the function's neither concave up nor concave down. It's where it's switching. And it's not a max nor a min. And we don't care what the function value is there because it's neither a max nor a min. So all we have is a local min here. So let's go back to our homework and see if that's right. See if we get the green screen. All right, so keep your fingers crossed for me. I have a local min at 9, negative 2,182. Let's see, submit answer. Sweet! Well done. Good job, everyone. Thanks for sticking with me. All right, here's my favorite part. Let's look at the function and see what was really happening at x equals 0 and 9. Remember, at x equals 0, we had a point where the first derivative was equal to 0. In other words, there was a horizontal tangent line. And sure enough, at x equals 0, you can see where the function was decreasing. It stops decreasing for a minute, right? The slope of the tangent line flattens out to 0, and then it continues decreasing after x equals 0. So we didn't have a max or a minimum there. But at 9, check that out. What a fun graph this is. At 9, that's where it stops decreasing and starts increasing. So here's where the first derivative was equal to 0. And then also, taking the second derivative at x equals 9, we see that the function is concave up, at least at x equals 9, which tells us that it must be a local maximum. Good stuff.